Today my lecture is on topic Thevenin's theorem. This is from module 2 and this topic Thevenin's theorem is mapped to um, course objective number 3, that is make use of theorems and graph theory to simplify complex electrical circuits. Make use of the theorems and graph theory to simplify complex electrical circuits. This is the module 2. So the module 2 today I'm starting. Module 2, uh, it is about the various network theorems and network topology. So the theorems here are superposition, reciprocity, Thevenin's, Norton's, maximum power transfer for DC excitation circuits, only for DC circuits, these theorems. And then next part of this module is about network topology. So under this network topology, what are the basic terms related to that definitions, that is, and then graph, tree, incidence matrix, basic cut set and basic tie set matrices for planar networks. Okay, today I'm going to talk about this Thevenin's theorem and problems based on that. Okay, first, what is this Thevenin's theorem says? What is the theorem statement? The theorem states that any linear bilateral network, that may be a DC network or AC network, containing several voltage and current sources and resistances, can be replaced by a single voltage source, one voltage source, that is called VTH, Thevenin's voltage, that is nothing but with a single series resistance. So here the theorem statement is any linear bilateral network. Okay, the network is a linear, having the linear elements, having the bilateral, the elements are bilateral. So we know that what is meant by linear element and what is meant by a bilateral element. So that network have this, okay, elements, type of elements, okay, and then having several sources, voltage sources and current sources, and also the elements, that may be a resistance or inductor or capacitor, can be replaced by, can be, number of elements are there, number of sources are there in the network, it can be replaced by whatever may be the network having number of sources, number of elements. It may be a big network, huge network, can be replaced by, according to this theorem, one voltage source, one single voltage source, that is called here Thevenin's voltage. Thevenin's voltage, that is denoted with VTH. That is denoted with VTH with a series single resistance. With a single resistance, that is here in series with that voltage source. That is the meaning of that. Okay, so that resistance is called Thevenin's resistance. That single series resistance is called Thevenin's resistance, that is denoted with RTH. So here it is shown. See that in the down, the network, you can look at this picture here. A linear network containing several EMFs and resistances, network having several EMFs and resistances, having, and at its output terminals, okay, at its output terminals, that network output terminals A and B, there is a load resistance RL. Now this network replaced by, according to this theorem, okay, we know that what is that theorem, okay, in whatever may be the network, okay, it is a linear bilateral network basically, then the number of sources, number of elements can be replaced by one voltage source with a series single resistance. So here see that here you can see that this linear network containing several EMFs and resistances are replaced by a voltage source VTH, okay, VTH, and a series single resistance RTH. So now the load resistance is keeping, we are not disturbing that load output terminals and its load resistance. Okay, so this is the meaning of this. Need a network containing several EMFs resistances replaced by voltage source with a series single resistance. So that is a equivalent circuit of, this is the equivalent circuit of Thevenin's theorem. Okay. Now the procedure to apply Thevenin's theorem. The steps to apply Thevenin's theorem. So there are three steps. First one is find the Thevenin's resistance. Okay, there are three steps. First one is find the Thevenin's resistance. Then, so procedure to apply Thevenin's theorem. Steps to apply Thevenin's theorem. There are three steps. First step is find the Thevenin's resistance, and then how to find the Thevenin's voltage. That is also nothing but open circuit voltage. And then third step is Thevenin's equivalent circuit. So first step, how to find the Thevenin's resistance for a given circuit. So in order to find this, replace all voltage sources. Replace all sources by their internal resistances. Replace all sources by their internal resistances. That means voltage sources are replaced by short circuit and current sources are replaced by open circuit. In a given circuit, if there is a voltage source, replace that with a short circuit. If there is a current source, replace that with a open circuit. So that is a first step under this RTH calculation. Next, find the Thevenin's resistance, find the equivalent resistance RTH across the open circuited load resistance. Remove the RL, okay. Remove RL, that means the resistance where we are interested in finding the current. Remove that resistance and there find the equivalent resistance. That is nothing but Thevenin's resistance. Next, how to find the Thevenin's voltage. How to find the Thevenin's voltage. That is also nothing but, they call it as open circuit voltage, denoted with VOC. Okay. How to calculate it? Remove the load resistance in the given circuit. Remove the load resistance simply and don't disturb the remaining circuit, and find the Thevenin's voltage VTH across these terminals. Simply removing the load resistance, that means the resistance where we are interested in finding the current, remove that and there find the voltage, that is VTH. Okay, find the VTH there. That is the second step. Then third step is draw the equivalent circuit and finally find the load current. That means current in the element in which we are interested. So see that this is the equivalent circuit. Okay, so for a given circuit, whatever may be the circuit, it may be a small circuit or a big circuit having, okay, so then that simply replaced by a voltage source, okay, one voltage source with a series single resistance VTH and RTH, then the load resistance at its terminals, which element, the element where we are interested in finding the current. So that is here RL and the current flowing through that is IL. So this is the equivalent circuit. So from this Okay, the load current is IL is calculated as IL is equal to VTH by RTH plus RL. So this is the expression. So from this we can calculate the current flowing through that RL. That means current flowing through that element in which we are interested. Okay, how it is obtained? By applying the KVL. Yes or no? By KVL in the write the KVL equation in the loop. So I start from here. So minus IL RTH minus IL RL plus VTH is equal to 0. So from this, what is a IL taking common IL into RTH plus RL is equal to VTH. So from this, the expression for IL is given by VTH by RTH plus RL. Okay, VTH is calculated. We know how to calculate it for a given circuit. RTH is calculated. We know how to calculate that RTH also. And RL is a resistance, the element in which we are interested in finding the current. So at last that is a equation. So VTH or VOC, which is also nothing but VOC by RTH plus RL. So that is a procedure to apply Thevenin's theorem or steps to apply Thevenin's theorem. Next, take a problem, take an example to apply this Thevenin's theorem so that find the current in a particular element. So here the problem is given like this. Calculate the current flowing through 3 ohm resistor using Thevenin's theorem. Current flowing through given circuit. In the given circuit, we see that this is a 3 ohm resistor. So question is calculate the current in the 3 ohm resistor using Thevenin's theorem. So there are 3 steps. One step, first calculate Thevenin's resistance. Second step, calculate Thevenin's voltage. Third step, equivalent circuit. From that, finally calculate the current. So first step, calculate how to find RTH, Thevenin's resistance. So we know that replace sources by internal resistances. That means voltage source. In the given circuit, replace voltage source with short circuit and current source with open circuit. Then find RTH across the load resistance, open circuited load resistance terminal. So from the given circuit, okay, what is the given circuit? This is the given circuit here, and in this voltage source replaced with a short circuit and remove this RL. This is a element where we want to find the current. So here remove this and here find the RTH. So circuit is, this is a circuit, right? Now to find the resistance here, okay, we know that how to get the equivalent resistance. If this is a place where we want to get the equivalent resistance, okay, how to calculate? We start from other side. So we start from other side, reduce the network, finally get the equivalent resistance here. So if I start from other side, this 4 ohms and 5 ohms first step, they are in parallel. Yes or no? The current flowing through them is different. That's why that means they are in parallel. So 4 and 5. My first step is parallel combination of 4 ohms and 5 ohms. 4 ohms and 5 ohms. So that is nothing but 4 into 5 by 4 plus 5. So 20 by 9. Okay. Then second step. What is the second step? This 20 by 9 and 2 ohms are in series because same current flowing through them. So that means they are in series connection. So this 20 by 9 added with 2, that gives the finally the Thevenin's resistance. So the value for RTH is given by 4.22 ohm. That is the Thevenin's resistance. Next, second step, to find Thevenin's voltage. Find the Thevenin's voltage. That is nothing but VTH. Thevenin's voltage. So, how to find Thevenin's voltage? We know the procedure. Remove the load resistance and find the voltage across that open terminals. Remove the load resistance and find the voltage at that place. So, take the given circuit as it is. Okay. So, only remove the element in which we are interested in finding the current. So, what is a circuit? Given circuit. This is a given circuit. Only remove this 3 ohm and find the voltage there. Remaining circuit is not going to be disturbed. So, this is the circuit VTH. Okay, to calculate VTH. So, now, how to find this voltage? How to find this VTH voltage here? Using our basic knowledge and solve this circuit to calculate this voltage. Now, how to get it from this circuit? The voltage here is nothing but voltage available across the 5 ohm resistor. The voltage here, that is VTH, is nothing but here in this circuit. Voltage across the 5 ohm. Because these terminals are open circuited means there is no current in the 2 ohm resistor. There is no current in the 2 ohm. So whatever the voltage here is nothing but voltage across this 5 ohm. So now, if we know the current in this 5 ohm resistor, then we can know the voltage across this 5 ohm. So first find the current in the 5 ohm. How to find current in the 5 ohm resistor? Assume a current in this loop, single loop, I. Assuming a current flowing in this single loop, that is I, and calculate that I. That is given by KVL equation 20 by 4 plus 9. That is what it is shown here. Okay, VTH is equal to I into 5. Okay, voltage across the resistor. And I is given by 20 by 4 plus 5 into 5, which gives 11.1 volt. 11.1 volt. So, that is a VTH value. Now, third step. Thevenin's equivalent circuit. Thevenin's equivalent circuit. It consists, we know that there is a 1 voltage source with a series single resistance. So, VTH is already calculated 11.1 and RTH is calculated 4.22 ohm. Now, show the resistance, load resistance. What is the load resistance for us? Here 3 ohm. And the current flowing through them is taken as IL. So, we have the IL. How to know? We know how to calculate this IL from KVL, basic KVL equation. Okay. Or if you remember this expression, you can directly substitute. Okay. So, IL is equal to VTH by RTH plus RL. All values are calculated. Okay, VTH calculated, RTH calculated, and RL is 3. So, substitute all the values, and here the IL value is given by 1.52 amperes. 1.52 amperes. So that is a answer. So calculate, question is, problem given is calculate the current flowing in 3 ohm resistor using Thevenin's theorem. So this is how finding the current, okay, finding the current in a particular element using Thevenin's theorem. 3 steps. Calculate RTH, first step. Second step, calculate VTH, second step. And third step is draw the equivalent circuit. From the equivalent circuit, calculate the current. Then one more problem, one more example problem. Here, calculate the current flowing through 2 ohms resistor using Thevenin's theorem. Current flowing through 2 ohm resistor. Okay, using Thevenin's theorem. So circuit is given like this. See that there are voltage sources B1 and B2. B1 is 28, B2 is 7 volts, and the resistances R1 is 4, R2 is 2, and R3 is 1. And this is the resistance where they are interested in finding the current. Now, so first step, find the RTH. RTH. So how to find RTH? Replace sources with internal resistance. So we have only voltage source. Replace the two sources with a short circuit. So that's why the circuit. The two voltage sources, okay, replace with short circuit, and remove the load resistance. The resistance where we are interested in finding the current. So 2 ohm resistor is removed, and there find the equivalent resistance. So that is what the circuit is shown. Okay. So this is Thevenin's. Okay. Circuit to calculate Thevenin's resistance. So now, how to find the equivalent resistance here? Okay, here look at the circuit. Use our basic knowledge. Using our basic knowledge, okay, the resistance here is given by this 4 ohm and 1 ohm are in different paths. Okay, they are in different paths. Currents flowing through them is different. Paths are different. So that's why the RTH is given by the parallel combination of 4 ohms and 1 ohm. So 4 into 1 by 4 plus 1. That means 4 by 5. So the value of RTH for this problem is 0.8. 0.8 ohm. Now second step. How to find Thevenin's voltage? How to find Thevenin's voltage? So we know that how to calculate Thevenin's voltage. Only one step. Taking the given circuit as it is, simply remove load resistance and there find the voltage. Remove the load resistance and at that place find the voltage. That voltage is called Thevenin's voltage. So here this is the circuit. See that, taking, okay, given circuit as it is, okay, showing sources and resistances, other resistances only in place of 2 ohm resistor, the resistor in which we are interested in calculating the current. Okay, that only removed, and there we are finding the voltage. That is called Thevenin's voltage. Now, how to solve this circuit to find the voltage, this voltage? So, using our basic knowledge again, okay. So, here the current, okay, this is a VTH with the polarities like this. Okay, so they are in different paths. Okay, 1 minute. So, the two element, okay, here if you see current wise, current flowing through each element is same. Okay, so there is only single one current path. So assume current flowing in the current is I, current flowing in the loop is I, and write down KVL and get the current in the circuit, current in the loop. Then get this VTH. Okay, by KVL, what is the equation? I start from here, minus 4I minus 1I minus 7 plus 28 equal to 0. So minus 5I plus 21 equal to 0. So I equal to 21 by 5. Now 21 by 5 amperes. Now how to find this VTH? So consider this side, this left side sub loop. You may consider other side also. You get the same value for the VTH. I am taking this left side and apply KVL to calculate VTH. Minus 4 into I minus VTH plus 28. From this, VTH is given by 28 minus 4I. So substituting for 21 by 5. Okay, our answer will be 11.2. If you consider the right side sub loop, you will get the one more equation, but the answer for VTH will be same. Plus I plus 7. So here you are getting 11.2. Okay. So that is how to calculate VTH for this circuit. Okay. Next, last step, Thevenin's equivalent circuit. So the Thevenin's equivalent circuit. Okay. So VTH we have 11.2 and it's 11.2, right? 11.2 and RTH is 0.8, right? Yes, 0.8 and RL is 2 ohm, right? So this is 2. So what is our substitute the values? 11.2 by 0.8 plus 2. So the answer is 4 amperes. The answer for this problem is 4 amperes. The current flowing in the 2 ohm resistor using Thevenin's theorem. Okay, using Thevenin's theorem is calculated. That is given by 4 amperes. So that is a answer for the given problem. Okay. Okay, that's all. For now, thank you.
Like, share and subscribe. Hit the bell icon for more updates.